Hello everyone, we are going to talk about the mass flow controller for gas of dry etch. The mass flow controller structure like this. This is the gas piping. And the flow this way, left to right. I will use the bypass piping here. Little bypass. And we put a heater, a resistor heater, resist heater 1, resistor heater 2. Call it R1, R2 to heat the gas. Then the gas flow to the main flow piping. And gas flow to here, we have a valve. It's formed just like a diaphragm. And there is a piezo assembly, or you can use the magnetic solenoid or the thermal heating foam etcher. This etcher to act the valve to up and down, and up, open, let the gas to flow, up more to open, wider to let more gas to flow, down to reduce the gas flow, down to the bottom to stop the gas, just like this. So this is the etcher valve, control valve to control the mass flow. This is this part is a sensor to sensor the mass flow to reach our set point. The principle is like this. If there is no gas flow. And R1 and R2 in the tube, in the bypass tube, heating by the wire, the resist, and the temperature, no gas flow, so temperature 1 and the temperature 2 at the same situation will be equal. We can see that the white line curve, this is the bypass piping position. And then here's the R1, R2, just like this. The R1, R2, this is the piping position. R1, R2, and no gas flow. They are in the same condition, so their temperature will be equal. Temperature 1 equal temperature 2. So the difference of temperature at this situation will be 0, just like the white curve. No gas. Then we let the gas through, and then R1 and R2, it has its own temperature and temperature 1 not equal to the temperature 2. In this situation, due to the different position, so you can see the R1 temperature is here and the R2 temperature is here. You see the yellow curve. The yellow curve, gas flow situation. And then the T2 and the T1, there is a difference. We call it a delta T. We use the T2 and T1 difference delta T to calculate to the mass flow. So we use the temperature difference delta to calculate the mass flow. This is the principle. It's very easy principle. So this is the NFC controller. Now the unit of the controller could be SCCM or SLN. SCCM equals the standard cubic centimeters per minute. SLN the standard liters per minute. The standard means that some area standard the SCCM, the mass flow could be 0 degree and 188. Some standard is 25 degree and 188. So the different country maybe use a different standard. So we got to know the standard to set up and use the right NFC for our process. For example, in Asia process, we use this kind of NFC, and in Europe area, we must use the same standard NFC to set the same set point value. If there is something wrong with the NFC, for example, the showing NFC value is different from the usual, we can check out the NFC and adjust a little bit the ratio, or we can call it offset linear, or the 0 point by the adjust the screw. This is the basic function. Adjust the 0 point or the ratio, you can adjust by the screw. Some complex NFC can connect and adjust by a PC the vendor has. Some days you cannot fix it just by the adjusting. You can renew a new one if you have a spare parts. But if you have no spare parts and you cannot get it very quickly, you can remove the cover and see the piezo assembly, just like this part. This is the piezo assembly. It may get dirty or damaged by the chemical gas for a long process using. You can renew a new one if you have spare parts, or try to clean it or repair it. Or you can probably you have a servo heat or solenoid valve kind. You also can renew the parts or clean the parts. Renew or clean the parts for trying. If you get dirty, you obviously. Then you can see the diaphragm inside to be a valve. Maybe you get dirty, you can clean it. If the diaphragm valve or its O-ring fail, you just renew it or clean it. Of course, some factory supply pressure. Some factory supply gas pressure from the facility not stable, may cause some NFC losing its accuracy. So please maintain the stable gas supply pressure from facility. It's very important. And then maybe you use the wrong range. Often the NFC designed for 10% to 90% accuracy. Just for example, if your flow rate usually set at 100 SCCM, 100 SCCM, the 10% and the 90% is the accuracy range, and then you may use the NFC to fit this range. There are many kinds of NFC, and they have many kinds flow range. You can use the suitable flow range NFC to install your piping. Maybe you use the wrong NFC. It made it out of range. Use range, or you renew a wrong NFC. Also cause it. So the MC is very important for process. If your process showing the wrong with wrong mass flow, the product or wafer could be in danger. So always spare NFC parts, especially a new part. It's very important to verify the issue or investigating your wafer issue. Prepare a new Spare NFC is very important. Okay, let's see you next time.